Look at your hands. Move them. To your eyes, that motion is perfectly fluid, a seamless glide through space and time. But what if that smoothness is a lie? What if the universe is hiding a terrifying secret right in front of you? Imagine a grand cinematic masterpiece playing on a massive screen. The characters weep, the stars explode, and the river flows. It looks flawlessly real, but stand close enough to the screen, close enough to touch the glass, and the illusion shatters. The story dissolves into static pixels. Top theoretical physicists are beginning to realize that our reality has pixels, not of space, but of time itself. We have always believed that time flows like a continuous, unbroken river, but the bleeding edge of quantum mechanics suggests something deeply unsettling. The river is a conveyor belt. Time does not flow. It ticks, it steps, it stutters. The universe is buffering. And at the ultimate foundation of reality, continuous movement is a physical impossibility. We are living G inside a cosmic render. For thousands of years, humanity assumed that reality was a smooth canvas. If you drop a glass and watch it shatter, it seems to transition effortlessly from whole to broken. If you zoom into a fraction of a second, you assume you can zoom in further, infinitely divided forever. But the universe has a hard floor. In the late 19th century, a physicist named Max Planck stumbled upon a fundamental limit written into the math of our universe. It is a number so unimaginably small that our minds are completely unequipped to comprehend it. We call it the Planck time. To understand just how small this is, think of it this way. If a single second were stretched out to last as long as the entire age of the universe, a Planck time would still be just a fraction of a blink. It is decimal zero, followed by 43 zeros, and then a 1. $TP equals \SQRT \frac \H bar GC5 \approx 5.39 times 10 to the negative 44 \text S $. This is not just a limitation of human clocks. This is a limitation of reality itself. Physics tells us that nothing can happen faster than this duration. No event can take less time. No particle can interact quicker. It is the absolute shortest tick of the universal clock. This leads us to a paradigm-shifting realization. If time cannot be divided into anything smaller than a Planck unit, then time cannot be continuous. It means the universe does not move smoothly from moment A to moment B. Instead, it flashes into existence, vanishes, and flashes back into existence, slightly altered. Every single second you experience is actually made of trillions upon trillions of static snapshots, stitched together so fast that your biology perceives it as life. You are not moving through time. You are being re-rendered over and over again. This is where the physics gets deeply haunting. If time has a refresh rate, it fundamentally breaks our understanding of motion. Think about a video game. When your character runs across a digital landscape, they aren't currently sliding across the monitor. The graphics card is calculating their position in frame 1, erasing them, and then rendering them a few pixels to the right in frame 2. If the frame rate is high enough, your brain perceives fluid running. But if the game lags, the movement becomes jerky. You see the gaps. The universe is doing the exact same thing, but its frame rate is so staggeringly high that the lag is invisible to us. But what happens in the dark spaces between the frames? If the universe updates at discrete intervals, then between tick 1 and tick 2, there is a gap, a cosmic pause, a terrifying void where time, space, and reality literally do not exist. When you wave your hand in front of your face, your hand exists at position X during Planck frame 1. It exists at position Y during Planck frame 2, but it never travels through the space between them. It cannot because there is no time available between those frames for it to make the journey. Motion is an illusion. We are re-teleporting through existence at the speed of reality's refresh rate. This isn't sci-fi speculation. It is the inevitable conclusion of trying to unify gravity with quantum mechanics. To make the universe make sense at the smallest scale, physicists had to strip away its smoothness. They had to pixelate the cosmos. And in doing so, they revealed that our solid world is shockingly ghostly. If we accept that the universe has a frame rate, we must ask the most uncomfortable question of all. Why? Why would the cosmos have a built-in processing limit? In our world, the only things that have frame rates and resolution limits are computers. We restrict the resolution of video games because our processors have a finite amount of computational power. A computer cannot calculate infinite detail instantly. It needs a grid. It needs pixels. It needs a clock speed to manage the flow of information. When we look at the universe through the lens of quantum physics, we see the exact same architecture. E-speed of light is not just a speed limit for photons, it is the data transfer speed of spacetime. The Planck length is the pixel size of the monitor, and the Planck time is the processor's master clock. Are we looking at the laws of physics, or are we looking at the hardware limitations of whatever is running us? This realization forces us to confront a profound sense of existential dread. It suggests that reality is not an inherent, natural truth. It is processed information. Every star that burns, every black hole that tears through space, and every tear that falls from your eye is a calculation. We are trapped inside a grand cosmic simulation, watching a movie that we mistake for solid reality. Imagine the scale of this operation. Every single atom in the observable universe, every electron spinning around every nucleus in the furthest galaxies, must be updated every single Planck second. The sheer computational weight is unfathomable. But what if the system saves power the same way our game engines do? In modern video games, developers use a technique called frustum culling. The computer only renders what the player is looking at. If a mountain is behind your character, it ceases to exist visually until you turn around. This saves precious processing power. In quantum mechanics, we see an eerie parallel known as the observer effect. Particles at the quantum scale do not exist in definite places until they are measured or observed. Before you look at them, they exist only as a haze of possibilities, a mathematical wave function. The moment a conscious observer or a measuring device interacts with them, that wave collapses into solid reality. The universe doesn't bother rendering the particle until someone looks at it. The implications are overwhelming. It means the cosmos is not a vast, objective machine running out there in the dark whether we are here or not. It is a responsive, dynamic render that constructs itself precisely when and where information is demanded. You are not a passive observer watching a pre-existing world. Your awareness is part of the system's rendering loop. We spend our entire lives worrying about the future and mourning the past. We treat time as this massive, heavy monument that crushes us, ages us, and eventually buries us. But physics has unmasked the monster. Time is not a solid wall. It is a flickering shadow. If you could step outside the cosmic frame rate, you would see that the past is just a previous saved state, and the future is an uncalculated equation. All that truly exists is the current frame, a single flashing pixel of the eternal now. We are fragile beings made of stardust, living inside a reality that blinks out of existence trillions of times every second. We disappear into the void between the frames over and over again, entirely unaware that we are constantly dying and being reborn at the fundamental frequency of the cosmos. The next time you look up at the night sky, don't see a vast, empty void of infinite space. See it for what it truly might be, a magnificent, hyper-advanced tapestry, a cosmic screen flickering in the dark. And as you sit there listening to these words, remember this. The universe just refreshed, and it did it again. And again, you are alive in the frame. But the true mystery is what waits for us in the spaces between.